Okay, trapezoid angle theorem. My sad trapezoid, this is the height. A trapezoid has two bases. A base here. I better make that singular then. And a base here. Okay? It does not matter. It's a base. Because I can flip this upside down. It's still a trapezoid. Okay? Now, this theorem says in a trapezoid consecutive angles. Well, what in the world are... let's make this T, R, A, P. Okay? I have trapezoid trap here. It says consecutive angles. Well, we learned this back in chapter 2. Consecutive angles are right after each other, so angles T and P would be, that's between a parallel sides. T and P are between parallel sides. They are supplementary. What does that mean? They add up to 180. So if this was 90, what's this one? Very good. Now the question here is, if this is 30, what's this one? Okay. Boom. That's what that angle theorem says. Okay. Does that make sense? So, on itself, it's not too exciting. Okay. Can I move on? The isosceles trapezoid symmetry theorem. Jamie, what's the definition of isosceles trapezoid? Rachel.
A trapezoid? Yes, as in isosceles trapezoid, if and only if it has a pair of base angles equal in measure.
Okay. The most common one you'll see me draw is this. Now, right now, is that a trapezoid? No. Right now, what is this shape? The quadrilateral right now. Now, what shape is it? Now it's a trapezoid. Now, what shape is it? Now it's an isosceles trapezoid, okay? Now, that's not what the theorem is about, but we just went over isosceles trapezoid. The perpendicular bisector of one of the base. What does that mean? Well, first of all, it's up and down. And since it's a perpendicular, it forms what kind of angle? 90. And it has to be a bisector, means it divides this exactly in half. So I'm guessing right about there. Now that's a perpendicular line coming through. Now I made it into a bisector. Okay. It's also the line of symmetry. What does that mean?
Fold it over.
Fold it over. Okay. And it's really not straight, I apologize. So if this angle was 60, what's this angle? What's this angle measure?
120.
What's this one? Okay. Yay. Now people handle trapezoids very well until I do this. And all of a sudden their brains stop working, okay? If you have to rotate the paper or something, okay? And we're not always going to see it in this form, and that's a terrible trapezoid, so I'm going to erase it right away. All right, next one. In an isosceles, I think I forgot a word there. Yeah, I think trapezoid's supposed to be in there. I lost my fifth block help for these. So again, I'm going to draw myself. Okay. Is it isosceles yet?
Nope.
Is it isosceles now? Yep. Okay. Basically what this says is if this is 20 feet, what's this going to be? 20 feet. Okay. This is not the height of the trapezoid, though. Be careful. That would be the height of a trapezoid. Okay. You're not going to need that until next chapter, but I'm starting to get you used to it right now. Because we're going to start finding surface. We're going to start finding volume and all this stuff. And then we're going to go to the three-dimensional world where we have to find volume of three-dimensional trapezoids, which, hey, they're always fun to draw, especially with me where you can't really draw very well. Huh. You know, well, you can see that line. You know, then you got to find a surface area volume of that. So that'll be, just give you a taste of what's coming. All right. Now, what shape is that? Quadrilateral.
You need the squares.
You need the squares. Very good.
That's right.
Now what shape is it? Okay. Let's go back. Whoa! Whoa, went back too far. What shape is this now?
That's right.
Very good.
It has at least one though.
What shape is it now? Very good. What shape is it now? A rectangle. Okay.
We're good at equal size.
Okay. Rectangles and trapezoids are always joined together. So here we go. The perpendicular bisectors of the sides of the rectangle. How many lines of symmetry does a rectangle have? How many ways can you fold it so it's completely folds on top of itself? Twice. Okay? Because you can fold it this way, and you can fold it this way. Oh, yay. More joy. Okay. Any questions? Now these are perpendicular bisector. What angle right here? 90. Okay. If this whole side was 20 feet, what's this side? 10 and 10, right? Does that make sense? Okay. We'll find out. There you go.